Hello, my little mathematicians. Today, we're going to use these dot plots to help us explore some of the vocab that's important to know when you're analyzing graphs. So first off, all three of these graphs are talking about students in band, chorus, and strings collected donations for a fundraiser concert to raise money for the music program. These dot plots show the results of asking 10 students from each class how much money they collected. Okay, so 10 students from this class, 10 students from this class, and 10 students from this class. So, between what numbers are the most common responses for each group of students for band? Right here. What was the most common amount donated? What do you think? Well, that would be $10, because you could see that there's most of 10 responses. There's 1, 2, 3, 4, 5, 6 people who had a response of having collected or raised $10 from band. What about chorus? Most people donated 20 from chorus. What about from strings? It's a tie between 40 and 50. So you can see that those are the highest ones here, and the 20 was the highest here, and 10 was the highest there. So dot plots is really nice that it very easily lets you look at maybe finding the mode of a data set. So here was 40 and 50 for the mode. This one was 20, and this one was 10. Okay. It also helps you answer some types of questions. Like, for instance, based upon the shape of the dot plot, which class likely raised the most money? What do you think? Okay. Well, I would say strings, because their data is skewed left, meaning that the majority of their values are all towards the right that are representing bigger donations. So strings probably raised the most money. That's even without me actually counting it up, because I could count each donation and see how much specifically each group donated. So here's 10, 20, 30, 40, 50, 60, 80, 100, 140, $200 for band. Okay, 0, 10, 20, 40, 60, 80, 100, 130, 160, 200 for chorus, right? And then for strings, 0, so 10, and then 50, and then 90, 130, 180, 230, 280, 340, 400. Okay, because I just added how, like, each dot, what it was representing to get the total. And so if you were to add them all, you could see, oh yeah, strings donated the most. But just quickly, like, without having to calculate it all and count it up, because if this was a larger data set than more than just 10 dots, that would be a pain in the butt to have to count up, right? So you can just kind of quickly glance and be like, hey, the majority of the data is over here representing bigger numbers, so they probably donated the most. And then the people who donated the least is probably this group, because they had the majority of their data down towards the left, representing smaller numbers, and most people donated 10, which was the least amount you could donate other than people who raised nothing. So some terms that may be helpful to use when you're asked to analyze data. Okay, a cluster of data is a group of data points that crowd near each other. Okay, so band is kind of clustered to the left, right? Strings is clustered over here to the right. A graph is skewed left when most of the data points are clustered at the higher values. Okay, so let's look at, we said that this one was skewed left. And it's almost a little bit backwards thinking, because you're like, wait a minute, most of the data values are here to the right. So why would I say that it's skewed left? Here's how I remember it. A data set is skewed if the vast majority of the data is located somewhere, and then there's a few screwballs or screw-offs that, like, aren't joining the rest of the group. Let's pretend they all need to move forward once they're all gathered together. Okay, and so these two little screw-offs over here are messing around, and now the whole group can't wait. They're like, come on, we need to be able to leave, but we can't because we're waiting for these two screwballs. I know that's a silly example, but that's how I remember it. Where are the screwballs located? They're over here to the left, so that's skewing my graph to the left. So now this group can't do what they're supposed to do. Okay, so it's skewed if the majority of your data is grouped together, clustered together in one location, except for one or two, like few little screw off points. And then wherever those screw balls are located, that's how the data is skewed. So this would say that it's skewed left. This would say it's skewed right, because you have these few here, and then the majority of the data is over here to the left. So it's skewed right. This one's skewed left, because here's where the screw balls are located. That one's a little bit opposite of what I think. Again, skewed right would be band, because the majority of the data is to the left. The screw balls are located to the right. Symmetrical graphs. They show the same number of data points above and below the middle. And you're like, what? Okay, so let's skip really fast to the definition of a peak. A peak forms when many data points are at one value. So do you see that band has a peak at 10, chorus has a peak of 20, and strings have like two peaks at 40 and 50. Chorus specifically has a peak in the middle, and then it's evenly distributed surrounding it. So here's your peak, and then you have two on this side and two on this side, one on the side of that and one on the side of that. So this is called a symmetrical graph, where you have a peak in the middle, and then it's evenly distributed on either side. That's called a symmetrical graph. Okay, and then finally, an outlier is a data point far away from the other data points. It doesn't quite fit in with the rest of the data points. So if you have outliers, that's probably going to cause a graph to be skewed, right? And depending upon where those outliers are, that's wherever they're located, wherever those outliers or screw balls are located, that's where the graph is being skewed. Hopefully, this helps you learn a little bit more of how to describe your different graphs that we've been talking about.